Hi everyone, thanks for being here today. My name is Singh. I'm currently a PhD candidate at the University of Nevada in Las Vegas. Thanks for taking some time to view our presentation entitled Mind Over Body, Creating an External Focus for Sports Skills. I'd like to also thank Dr. Wolf for her contributions to this project and her continued mentorship and support. It is well known that an external focus of attention on the intended effect of movements results in greater performance and learning relative to an internal focus of attention on body movements. When we think about creating an external focus, there are several different ways that this can be achieved. For example, the motion of an implement such as water, where authors here found faster swim times when performing under an external focus directed to the water as opposed to an internal focus directed to the hands. Another example is an image that refers to an implement such as the pendulum-like motion of the golf club. In this study, participants in the external focus group were more accurate and showed enhanced learning benefits compared to an internal focus group. Further, another example is a target or target location, such as the rungs on the vertex, which here led to improved jumping performance relative to concentrating on the tips of the fingers. And lastly, for instance, we have an image that actually refers to the body itself. For example, here, thinking about the thighs as lines between markers on the knees and hips actually led to greater performance on a static wall sit task as measured by time to failure and level of perceived exertion compared to focusing on the thighs themselves. This raises an interesting question whether complex task performance can be enhanced by a focus on an image that represents a body part rather than a focus on the body parts themselves. So the purpose of this study was to examine whether performance of a complex whole-body coordination task can be enhanced by focusing on an image of a body part rather than the body part itself. Now, based on a factorial design with one within participant factor, focus, and one between participant factor, the order of conditions, we conducted a power analysis and recruited 14 individuals who were considered novice volleyball players, accumulating altogether, on average, 2.85 years of recreational playing experience. We had asked each participant to perform a whole-body, dynamic, and continuous aiming task. As you can see in this video, this is just an example of the task itself. Now, each participant performed 2 blocks of 8 trials for a total of 16 trials. Each block was performed either under an external focus or an internal focus, and this was counterbalanced across participants. For the internal focus condition, we asked them to concentrate on their arms, and for the external focus condition, we asked them to concentrate on their platform. A platform was utilized to represent the area between the wrist and elbow. Now, these instructions were repeated before the start of each trial. The timer started when the participant initiated a self-toss of the ball to the target. If during the trial the ball hit the ground, participants were asked to just self-toss again and continue the task with the goal of maximizing the number of points scored. The points were recorded using a video recorder that was mounted on a tripod and facing the target. Now, as for the results, an external focus on the platform resulted in higher total scores compared to the internal focus on the arms. The total score for each 45-second trial was a function of both the number of passes and the accuracy with which the target was hit. Therefore, we also analyzed each of those components of performance. The average number of passes completed per trial showed that in the external focus condition, participants performed more passes than they did in the internal focus condition. As for the average accuracy scores, they were similar in the external and internal focus conditions. Now, given the average accuracy scores were already relatively high, namely 2.7 for the internal focus and 2.8 for the external focus out of the possible 4 points, there was limited room for improvement with regard to accuracy. So it is therefore perhaps not surprising that the number of passes had a greater influence on the performance differences between conditions. I also want to note that for the respective dependent variables, total scores, number of passes, and accuracy scores, there was no effect of order or interaction of focus and order. Now, in conclusion, what we found was that an external focus on the platform was more effective for performance than an internal focus on the arms. Utilizing an image of an external object that replaces a body part resulted in performance advantages compared to an internal focus on the same body part. Now, the total score for each 45-second trial was a function of both the number of passes and the accuracy with which the target was hit. We found that an external focus increased the speed of passes, which is in line with previous research reflecting enhanced efficiency and fluidity of movements. And finally, coaches or athletes themselves can create images to facilitate motor coordination for effective performance. Now, the present findings provide experimental evidence for the effectiveness of external foci that make use of images of bodily movements or postures, while at the same time reducing a focus on the body. And with that, I want to thank you for your time and open it up for any questions.